YouTube channel. In today's lesson, I'm going to be teaching you capacitors and capacitance. What is a capacitor? A capacitor is a device used for storing what? Charges. Okay? A capacitor is a device that helps to store charges. Now, a capacitor differs entirely from the device called electrophorus. For electrophorus, For electrophorus, please, it must be noted, it is used to store large numbers of similar charges. So, an electrophorus is a bigger device because it can store more charges than a capacitor. But as for a capacitor, it consists of two metal plates. This must be noted. It consists of two metal plates that are separated by an insulator. The insulator is better called a dielectric. You must note it. Now, these two metal plates is given to you on the board. This is a diagram of a capacitor. Now, this is the positive metal plate, while this is your negative metal plate. Okay, as you can see, a capacitor comprises of two equal opposite charges, which is positive and what? Negative. Okay, now in between a capacitor is a material known as an insulator. What is an insulator? Don't forget that an insulator is a material that does not allow what? Current or heat to pass through them. So to prevent your capacitors from discharging the charges that has been stored in it, you must construct it this way so that the two plates will be insulated from each other. The insulator is better known as what? A dielectric material. An example of your insulator is your plastic or your glass or wood or even air or vacuum is also an insulator. Don't forget that air or vacuum cannot conduct wetin na current. So you can put a plastic here, you can put glass here, you can put polythene here, you can put any other insulator here. Now the only material that cannot be used as an insulator is metals. Don't forget that metals are good conductors of what? Electricity. More so, you cannot use water as a dielectric material because although water is a poor conductor of what? Electricity. Okay, but it's very difficult to see pure water. Most waters that we have usually contain minerals, which will what? Become a conductor of what? Current. So it must be noted that metals and water cannot be used as a dielectric what? Material. So a capacitor helps to store charges, but electrophorus is a bigger device that stores large number of similar charges. But our topic today in this video lesson is capacitors and what? Capacitance. So take note, what is between the plate of a capacitor is a dielectric material like what? Wood, like what? Glass, like what? Polythene. It must be noted. Okay, so take note of that. Now we are going to go over to what we call a capacitance. But before we do that, don't forget that in every circuit diagram where you see a capacitor, you should be able to distinguish this capacitor from yourself. What is the symbol for a capacitor? For a capacitor, the symbol is like this. The two poles, this one and this one, of equal length. So it's called capacitor. Now, if one is longer than the other, it's known as a cell. A cell combines together to form a battery. Please note it, okay? Now, let's go back to what we call capacitance. A capacitance is the ratio of charge on either plate or conductor to the potential difference between the plate. To the potential difference between the plates. Please note it. A capacitance is the ratio of charge on either plate or conductor to the potential difference between them. What is the formula for the capacitance of a capacitor? Capacitance, as the definition implies, is the ratio of charge to potential difference, which is voltage. Okay? Please, you must note that capacitance is measured in what? In farad. It must be noted, F. Or from the formula, remember that your charge is in coulomb, potential difference is in volts. So you have coulomb per volt. That's what we have. So the unit for the capacitance of the capacitor is farad, which is F, or coulomb per volt. Please note this, that this is the SI unit. That means the unit accepted all over the nook and cranny of the world. While this is called the derived unit. So the SI unit for capacitance of the capacitor is farad, but the derived unit is what? Coulomb per volt. Now, what is your C? C represents quantity of charge. C represents quantity of charge. Okay? Your quantity of charge is measured in what? Coulomb. And the unit is C. V represents what? Potential difference. Potential difference. Your potential difference is measured in volts and the symbol is V. More also, recall, please take your book and your pen and write this formula. Quantity of charge is equals to current times time. V, which is your potential difference, is equals to work done per unit charge. Please, it must be noted. Okay, so quantity of charge is current times time. And don't forget, the unit is weighting, coulomb. Potential difference is work over charge. And the unit is what? In volts. Coulomb is the SI unit for charge. Volt is the word SI unit for what? Potential difference. But from the formula, we can get the derived unit. Okay, the derived unit for quantity of charge, which is current times time, is ampere for current and seconds for time. But for potential difference, it is joule for work and coulomb for what? For charge. So please notice that. Now we're going to take just a question, then we continue from here. Let's take a look at this question. According to this question, we have a 5 volts battery is connected across the plate of a what? 2.0 micron farad, okay, of uncharged parallel plate capacitor. The question says, the charge on the capacitor after a long time is what? Now let's first of all bring out our parameters so we'll solve this question. Now the voltage according to the question is 5 volts. Don't forget that this voltage signifies your potential what? Difference. Okay? Across a parallel plate of, this is the capacitance of the capacitor. So we have capacitance of the capacitor equals 2.0 micron farad. Now, in the normal sense of view, whenever you are given a value in micron farad, you are supposed to divide it with 1 million, or you simply just multiply with 10 raised to the power of minus 6. For instance, if we have a capacitance of 25 micron farad, how do you convert this? Because of this micron, you will multiply it with 10 raised to the power of what? Minus 6. And when that is done, you will have 2.5 times 10 raised to the power of minus 5. It is no longer in micron farad, it's now in what? In farad. Okay, now I saw a question in OAU Post UTME Park. They said 1000 micron is equivalent to what? 1000 micron is equal to what? Whenever you hear the word micron, it signifies this symbol. Are we together? Yes. Now, if it signifies this symbol, what do you have to do? To move from micron, you must always multiply with 10 raised to the power of minus 6. So if I have 1000 micron, I will multiply with 10 raised to the power of minus 6. Don't forget, you have 1, 2, 3. You have 3 zeros here. So if you add the 3 zeros to this place, you are going to get 10 raised to the power of minus 3. So you have converted it from micron. So to remove from micron, you multiply with 10 raised to the power of minus 6. Don't forget that. It must be noted. But according to this question, if you look at the option very well, you will see that the micron is still in the option. So we don't have to convert this at all. No, it should not be converted. So what do we have to do? Very easy. This is what we have to do. Remember that we are looking for the quantity of what? Charge. And remember also that capacitance is the ratio of the charge to the potential what? Difference. Therefore, our charge will now be equals to what? CV. That is to say you have cross multiply. And then Q will be equals to C, which is what? 2 times voltage, which is what? 5. So what would that give us? 10. We are supposed to have 10 coulomb, but because we didn't convert this, so we have 10.0. However, micron coulomb. This becomes the answer to the question. Yes, it is very cheap because you know it now. So the answer is what? B. Let's move ahead to what we call factors affecting the capacitance of a capacitor. Please, you have to remain in this channel because I have classwork for you to do. We are going to look at, we are in the second phase, still on this topic, phase 2. We are going to look at factors affecting the capacitance of a capacitor. Don't forget that capacitance is the ratio of charge on either plate or conductor to the potential difference between the plates. Now, what are the factors that determines the ability of the word capacitor to store charges? Now, here are the factors. Factor number 1, distance between the plates. Distance between the plates. Please take note of that. And here we have it as D. Now, what is the relationship between the distance between the plates and the capacitance? The capacitance is inversely proportional to the distance between the plates. What does that mean? It means that when the separation is big or large, then the capacitance will be very small. For instance, this is one of the plates and this is the other plate. By the time you increase the distance between the plates, as you begin to increase distance, you are reducing the capacitance of the capacitor. So there is an inverse relationship here. So when this becomes maximum, the capacitance will become waiting at minimum. Are we together? Okay. Now, number 2, we have surface area of the plate. Surface area of the plate, which is denoted as what? A. Okay. Some plates are very large, while some are what? Tiny. The larger the plate of the capacitor, the greater the capacitance. Therefore, capacitance is very proportional to the what? Area of the word of the plates. Are we together? So the area plays a crucial role in the capacitance of a capacitor. Now, number 3, we have what we call the thickness of the dielectric material. The dielectric material. Remember I told you that the dielectric material is insulator that what? Insulates these two plates, which is this. So the thickness, the capacitance is very proportional to the thickness. This must be noted. It is proportional to the thickness of the plate. The thicker this material, the greater the capacitance. Number 4, we'll talk about the shape of the plate. Shape of the plate. This can also be recorded as the nature of the dielectric material. Then you have shape of the plate. Now, mathematically, we are going to combine this and this together. Let's combine these two together. Let's combine the capacitance as related to distance between the plate and related to the area of the plate. Let's do that quickly. In general, we have discovered that the capacitance is directly proportional to the area but inversely proportional to the distance between the plates. Therefore, we have C, remember you must remove your proportionality sign and introduce your constant, will be equals to permittivity A all over what? D. Take note, where the symbol is called permittivity. Permittivity. And the unit for permittivity is farad per meter. Please note it down. It must be noted. A, you know your A signifies your word area and your D signifies your word distance. Now listen, just like I told you, we have what we call the dielectric material. If the dielectric material, as in the insulator that insulates both plates, if it is air or if it is vacuum, we are saying that in air or vacuum, this permittivity that you are seeing here, which is epsilon, will be equals to E naught. Take note of that. So, if we are talking about air or vacuum, as in if it is air that separates these plates together, that's when you see this symbol. So whenever you see this symbol, know that it's got to do with what? Air. So if you have air separating material, this one has a constant 8.85 times 10 raised to the power minus 12 farad per meter. This is called the permittivity of free space or permittivity in a vacuum. It is constant. So if it is air or vacuum that insulate the plate, then your formula will become capacitance equals to permittivity in air, area over weighting over distance. So this is what you have. Okay, so sometimes you can see this. This one is the general formula. This one is referring to air being the insulator between the plates. Okay, now I'll give you another instance. In a material medium, what do I mean? I'm saying if there is a glass between the plate, as there's a material is recorded there. If there's a glass between the plate, then this guy, which stands for the general permittivity, will become E permittivity N, which means permittivity of the material. At that instant, capacitance will become permittivity of the material, then A over weighting over D. It must be noted. So this one is when we are referring to air or free space. This one is when you are referring to a medium, e.g. glass or polythene or paraffin, but certainly a material that is standing between the two plates of the word capacitor. More also, class, we'll talk about relative permittivity. Let's talk about relative permittivity. Please, I want this to be noted down. Take your book and your pen and note this down. Relative permittivity is also called dielectric constant. Yes. So whenever you hear dielectric constant, know that it's referring to relative permittivity. And this is relative permittivity. Relative permittivity is equals to the permittivity of the medium over the permittivity of free space. Or relative permittivity is the capacitance of the capacitor in the medium over the capacitance of the capacitor in free space. It must be noted. So your lead permittivity is called the dielectric constant. So take note, this is called permittivity of the medium. Of the medium, it must be noted. This is called permittivity of free space. Remember I told you that the permittivity of free space has a constant 8.85 times 10 raised to the power of minus 12 farad per meter. Okay? Then your Cm is capacitance of the capacitor in what? In a medium. C0 is the capacitance of the capacitor in free space. Please, it must be noted. Now, if you have gotten all of this, it means that you'll be able to solve questions involving factors affecting the capacitance of the capacitor. Okay, don't skip this video. Let's quickly take this question. What's this question to solve? This is question number 2 and question number 3. By the time I'm done solving this question, I'm going to give you an assignment to solve, okay? Now, the question number 2 said the capacitance of a capacitor is 20 micron farad in air. Remember what I told you, in air, it means that C0 is 20 micron farad, okay? That's in air. Note it. And 60 micron farad in the presence of a dielectric, which means the capacitance in a medium is 60 micron farad. Okay? Now, what is the dielectric constant? Remember I told you that the dielectric constant is also called relative permittivity. Okay? So your relative permittivity is what we are looking for. Very easy. Remember, relative permittivity is the capacitance of the capacitor in a medium over the capacitance of the capacitor in the what? Free space. So what do we have like that? Very easy. You see that this one is what? 60 and this one is what? 20. If 0 cancels 0, 2 going to 60, relative permittivity, which does not have any unit, will be equals to what? 3.0. The answer is what? A. Okay, so let's quickly solve question number 3. Of area. Okay, let's do that quickly. The area of the capacitor, area is 9.6 times 10 raised to the power of minus 3 meter squared. That's the area. Separated by dielectric constant, okay, which is relative permittivity. Don't forget that. It does not have any unit because it is defined by the ratio of the same quantity. Okay, calculate the capacitance of the capacitor. We don't know this. If the permittivity of free space is equals to what? 8.85 times 10 raised to the power of minus 12 farad per meter. Wow, very easy. If you come across this question in your exam, how will you solve it? Very easy. Remember, capacitance of a capacitor could either be in free space or in a medium. Okay? From the question given, they gave us the dielectric constant at 900. And if they give the dielectric constant and also measure air, it means that there must be a medium. Yeah, there must be a medium for you to have a dielectric constant. Why did I say so? Dielectric constant is the permittivity of medium to permittivity of free space. So if you have this, it means that it must be in a medium. Therefore, capacitance of the capacitor in a medium is permittivity of the material in a medium times A over weighting R over D. So how do we get this? The question is, how do we get permittivity of the medium? Very easy. Let's do that quickly. Relative permittivity is permittivity of medium over permittivity of free space. So that means permittivity of medium is relative permittivity, which is what? 900 times permittivity of free space, which is what? 8.85 times 10 raised to the power of minus 12. So this is the permittivity of the word of the medium. Okay, now we have capacitance with capacitor in the medium equals to permittivity of the medium is what? 900 times what? 8.85 times 10 raised to the power of minus 12. This is the permittivity of the medium. Okay, times area. What's the area? 9.6 times 10 raised to the power of minus 3. Okay, then we have distance. Wow, it's like distance wasn't given. Cut it for me. Yeah, so this is the thickness of the material. Okay, I think I didn't include it, but I just got it now. This is the thickness of the material. The thickness signifies the distance. So you put your distance 2.25 times 10 raised to the power of minus 12. Okay, so what do we do now? Very easy. Let's do this quickly. Remember that if you are writing JAM, or you are writing post UTME exam, or you are writing nursing exam, the calculator that will be programmed in the system will not be able to get this exponential value. So what do we simply do? We are going to multiply this number as in 900 by 8.85 and 9.6. Let's do that quickly. 900 times 8.85 times 9.6. Okay, that will give us 76464. So if we multiply this, we have 76464. Good. Then you pick one of the 10. So you have times 10 raised to the power of minus 12. Then you add this, which will give us minus what? 3. All over here you have 2.25 times 10 raised to the power of minus 12. So what do we do? Very easy. Now we are going to divide this by this, as in we'll divide these two, okay? But don't forget that if you combine this together, you are going to get minus 15, like minus 12 minus 3. It's supposed to be minus 12 plus minus 3. The same with minus 12 minus 3. So you have minus 15 here. So if we divide these two, we'll pick one of these 10. Let's do that quickly. We have divide by, that's 76464, divide by 2.25. That will give you 33984. So if you divide this by this, you have 33984. Then times 10 raised to the power. This power is already minus 15. Then when this one comes, it becomes minus 12. So you have 33984 times 10 raised to the power of minus 15. Minus will give us what? Plus 12. So what would that give us? You have 33984 times 10 raised to the power of what? Minus 15 plus 12 will give us what? Minus 3. So if we convert to the appropriate form, we move our decimal from here. 1, 2, 3, 4. So you have done that 4 times. You add 4 to this number. So our answer becomes equals to, let's write it out here. You have 3.39. You can leave the others. 3.39. Okay. 3.398 times 10 raised to the power of 1. Yeah, raised to the power of 1. Because you have moved 1, 2, 3, 4. So you add 4 here, so you have 1. This becomes the capacitance of the word capacitor raised to the power of 1. In what? In farad. Remember that the unit for a capacitor is what? Farad. So this is the answer to the question. I'm going to leave you with a question. By the time you are done solving the question, send the answers to me in the comment section. Now I'm leaving you with this question 1 and question 2. By the time you are done solving this question and also answering these, send the answers to me in the comment section. If today is your first time for coming across the H2 channel, Please do well to subscribe for more content. I'll see you in my next video.